All right, we're going to look at a few of these inequalities to see how they work on a number line. So we've got this statement, and we just need to make sure that we know how to read it. So this says all numbers that are greater than 4. So we need to represent all numbers that are greater than 4 on a number line. So we're going to put a circle at 4, and we have to think about if 4 is included in this inequality. Is 4 greater than 4? And the answer is no, it's equal to. So 4 is not a solution to this inequality. So I am not going to shade in the circle at 4 because we only shade numbers that are solutions. And 4 is not a solution. So when I look at my number line, I need to shade in all the numbers that are greater than 4. So I would want to shade on my number line in this direction, showing all numbers that are greater than 4. Look at another one. This one says all numbers that are less than or equal to -2. So we're going to be at -2 on the number line, and we can think to ourselves, is -2 a solution to this inequality? So is -2 less than or equal to -2? And the answer is yes, it's equal to. So since it is part of the solution, we have to shade it in. And then we have to think about what numbers are less than or equal to -2. And that would be these. Now we can always test a value. We can say, well, what if x was -3? Would that work? And so we go back up here and we check it. Is -3 less than -2? And the answer is yes. So that means I know I shaded the correct side of my number line. If I tested out 0, and I put a 0 here instead, is 0 less than or equal to -2? And the answer is no. So I should not have 0 being shaded. Let's look at another one. 5 is less than all numbers. So we need to shade in all numbers where 5 is less than that. So let's start off here. We're going to be at 5. Is 5 less than 5? And the answer is no. So we're going to leave that open because 5 is not a solution to this inequality. From here, we're going to look at what side of the equal sign we can shade. And sometimes when the number is written first, it can be confusing. So this is why it's nice to be able to just test a value. So I'm going to test a value of 7 and I'll test a value of 3 and see which side works. So let's test out the 7. Is 5 less than 7? Yes. So that means that 7 is part of the solution, so that's the side that should be shaded in. We can check over here with 3, is 5 less than 3? And the answer is no. So 3 should not be shaded. 3 is not a solution, so we should not shade that on the number line. Let's look at another. This says 8 is greater than or equal to all numbers. So we need all numbers where 8 is greater than that. So we'll be at 8. We have to decide if we're going to shade it or not. So we'll test out 8. Is 8 greater than or equal to 8? And the answer is yes, it has that equal to, so 8 is part of the solution. Now, we want 8 to be greater than all these other numbers, so we can test out some values. We can test out 10 and we can test out 6. So is 8 greater than or equal to 10? 8 is not greater than 10, so 10 should not be shaded in. Let's check 6. Is 8 greater than or equal to 6? And the answer is yes. 8 is greater than 6, so that means that 6 is part of the solution, so that's the side that needs to be shaded. Now we need to represent the numbers that are shaded on this number line. So we're trying to compare all numbers, and we're calling all those numbers x, and we're trying to compare them to -3. So we just have to think about what numbers are being shaded. Are we shading in numbers that are greater than -3 or less than -3? And the answer is we're shading in numbers that are greater than -3. Now we need to look at the circle. Is -3 part of the solution? Since it's an open circle, it is not part of the solution. So it will not have that equal to line underneath the inequality. So my answer is simply x is greater than -3. We could also write it with -3 first, and it would be -3 is less than all numbers. So either way is a correct way of writing what we see on this number line. Let's look at one more. We're trying to compare all numbers to 6. And we have to think about what numbers are being shaded. The numbers on the number line that are being shaded are numbers that are less than 6. And then we have to look to see if 6 is part of the solution. Since the circle is shaded in, we know that 6 is part of the solution. So that means it needs to have the equal to line because x needs to be less than or equal to 6. If you like writing the number first, it would look like this. 6 is greater than or equal to x. Both ways correctly represent what we see on the number line.